First, we will see need what is the need of going for any power or energy management strategies. So very importantly, it is need because if I am employing the any power and energy management concept only, I can achieve certain goals. What is the goal? See, in any combination, in anything, if I want to have a management means, so I want to manage means, there is a through two aspects only will be there. So what is the two aspects? The purpose of any management is we have to minimize the waste, we have to minimize the effort, we have to minimize the losses and etc. And obviously we have to maximize the efficiency, maximize the profit, maximize the fuel economy, maximize the performance, and maximize the effort. Okay, so minimize the effort and maximize the outcome of the effort. Okay, so this is what any management, it is having a two objectives only. So it is having certain a set of a minimum and certain set of maximum. So obviously they are interlinked only. If you are minimize, if you are minimize the losses, automatically what will happen as a result of that, I can get a maximum efficiency. If I minimize the cost, okay, obviously I can have a automatically maximize the uh, product sales. So automatically so everything is interlinked only. So if some of the things are maybe indirectly interlinked only. Okay, so sometimes we have to identify optimum point. So there is no any fixed points in any engineering problems that this will all give minimization, this will all give maximization. So there is a optimum point also, because all the engineering problems, it is not only a straight away a statement, it is having a constraints, it is having a constraint. So suppose if we want to say example for that, you are all know that ceiling fan is there. Ceiling fan is the very good engineering product. Okay, so what it is giving, it is circulating, it is making forcibly circulating the air that is available in any room or where it is fitted. So it is not creating any air. It is not creating air. So air should be there, but the airflow, it is facilitating the airflow in a very fast manner. So in what speed the fan is running. So it is a very good engineering product. But as far as the safety is concerned, if you see very often, so maybe due to the failure or due to the lack of safety measures that incorporated, so occasionally you may heard some newses that so the particular ceiling fan fall on the head of the particular person, got injured or got died, or maybe head injury, or it is damaged the goods under the particular, or any goods under kept under the. So very occasionally we are getting the news like that. So why it is happening? Why it is happening? Suppose if I am creating any fan, so which can facilitate the airflow in a very very fast manner. Okay, but every product having a exit. Okay, exit of the product. So every product during the life period, so automatically after the life period is over, it is having a exit. So that exit should be the very safe exit. So that is the primost duty of any engineers. So those who have developed the product or creating or invented the product, so there should be a strategies. Okay, or there should be a facilitate. Okay, so we have to facilitate the particular product to a safe exit. So if it is stop running, if it is not performing, or due to the life period is over, okay, so all the windings, all the material, all the composite material that we have used in the particular product, okay, due to the aging, so the life period over means, so it has to stop performing. But instead of that, so like the previous example I told, so due to the bearing worn out, due to the bolt and nut that, okay, so that corroded and etc. Due to that, if it is fall down on the user, or if it is totally fall down, okay, so what will happen? It is not having any safety measures. But that has to be ensured. At the same time, if I am incorporating the safety measures, the probability of the particular questioning of the safety measure is more. Okay, say for example, I want to incorporate a safety measure in which fan even it will not shake, or even it will not a small it will not move. Okay, always bearing will be assured bearing performances. So automatically what will happen means the cost of the product will be increasing. So this may, if you take any product, so any commercially available product, due to the majority of the cost, okay, majority of the cost or the production cost is involved in the safety measures only, to ensure the safety measures only. Okay, so a proper covers, a proper container, a proper, suppose even for safe exist also, so there should be a proper safety measure should be incorporated. In order to incorporate thoroughly, they have to additionally, they may incorporate some other mechanism inside any product. So that will assure that safe exit of the particular product. Okay, so in this case, I am going to incorporate some mechanism, some additional hardwares or additional some software means, then automatically the production cost will be increasing. So then we have to assess what is the acceptable risk, what is the acceptable risk of the particular product. So up to that I can able to only providing that. So what are all the probability of risk is totally very very less. Probability of less, so that cannot happen. Or maybe once in some 1 crore product, once in 10 crore product only, maybe such a defeat or such a kind of accident may happen. Means if you are incorporate the safety measures to overcome that, so automatically that will be additionally incurred some investment that will make the particular product as a very costly one. So optimum, so that is called optimization. So even though we are very much interested in minimizing the losses, minimizing the damages, minimizing the effort, and maximizing the efficiency, maximizing the profit, maximizing the performance, all the positive things we want to maximize means, so there should be a, there is a in between that, there is a one point is there. So that is called optimization. Okay, I want to minimize, I want to minimize. So, but constraints are up to this much only I can minimize. I want to maximize. I want to maximize, but the production cannot be happen more than its particular number in a particular day, or using particular machines, or using particular methodology, or using particular technology in the particular day. So these are all the some constraints. So when we are talking about the optimization problem, so the mainly the constraints are deciding the optimal point. Constraints. So in all engineering problem, so whether we want to minimize and maximize, so as many constraints are there, so automatically it is a complex one. So finding out the optimal point is a complex one. So that is what here. So here the energy management and power management is nothing to do. We want to engage all the available existing designed components. So when they are designed the vehicle, when they are derive the design also, they have very carefully consider how to size the motor, how to sizing of components, and where should be fitted, how much the space efficiency, etc. Everything is taken care. At the same time, they have to go for which type of strategies or which type of energy management or power management strategies that is going to be incorporated in the particular design. That also should be well in advance known. Then only they can able to very effectively perform. Okay, so if you see that it obviously that involves the distribution of energy. So I am using a motor as well as internal combustion engine. So I need at particular instant I need certain amount of energy. So that energy has to be derived, or we are going to get it from the both the machines. At what proportion? At what proportion? That proportion should assure that a proper system, fuel, and proper minimize the losses from motor, and as well as it should ensure that using a battery or any energy storage system, it can sustain for whatever may be the assured period of time. So since the resource is not unlimited, it involves the best allocation of resources with the objective of minimizing fuel consumption while observing various constraints. Thus, a good energy management that leads to a better fuel economy, and as well as main importantly lower emission, and it also leads to enhanced life of devices. Okay, so So it is not only our aim is to get a better fuel economy, lower emission, whatever may be the associated components that dedicated for the particular objective, that should be having a at least to the assured life period. Okay, life of the device it should work. So, for example, by controlling the state of charge, okay, of a battery properly, it may be possible to better maintain the battery health, thus requiring less replacement. So, if I'm taking care about by means of some strategy, so I'm taking care about the state of charge of my battery. So automatically it will maintain the battery health automatically. So I need to I can able to use the particular battery up to a assured period. Okay. So if I am not maintaining the particular state of charge battery, so automatically it need a replacement well in advance. That is before the assured period. I may be in the position of replacing the battery. So automatically create that will create the cost per kilometer. Okay, that will create increase in the cost per kilometer. So automatically, to more precise, power management has a goal of taking a holistic view of the system, not just from the point of view of fuel economy. It is to achieve a minimum life cycle cost of the system. So that power and energy management is a post-design situation. So as already I told that. Okay, so vehicles are designed with a lot of considerations, space, weight, so where we are going to place the battery, where we are going to have the how we are going to have the powertrain, okay, powertrain configurations. So what is the rating of motor, what is the rating of internal combustion engine, so whether it is going to be a plug-in hybrid electric vehicle or hybrid electric vehicle, mild hybrid. So a lot of things we are already designed, but as far as the power and energy management, it is a post-design situation. So post-design situation. So if I am properly identify the proper strategy of power and energy management, only I can able to get a better performance because it is a post-design. So definitely, strategy maybe differs. So strategy may be a different one. I have to identify a proper strategy. So it is an operational level strategy after the system has already been built and deployed. Okay. Whereas the design optimization and the component sizing are done before the vehicle is made. Okay. So knowing beforehand and what kind of power management strategy and algorithm. So especially, so this is a kind of a non-linear problem. So there is a non-linearity is there because the vehicle has to be run in a plain terrain, uphill movement, downhill movement, sometimes a different environment it has to operate. So it is not going to be there. If I'm suppose usually engineers what will do is so they will just do the mathematical modeling of the problem. Suppose any problem in terms of statement, so it is a engineer styles that we will usually convert it to a mathematical problem. But as far as this type of problem, I cannot have a fixed mathematical modeling of the problem because whatever may be the my vehicle I have designed, that is not going to be encountered. That is not face fixed type of problem. Okay, so maybe after components warning out that due to the aging of component after certain years, so I may be having a some decrease in the performance. So I cannot expect it. So I cannot. So for that I need understanding. I need a mathematical modeling of each component and its influence on the vehicle performance. So on each day after certain years after certain period how it will be like that. So it is a very very difficult, so automatically that will make my problem as a very complex one. So solving that particular complex problem also need to be a very difficult one. Instead of that, what the people are doing is, so instead of that they are using the soft computing techniques. You know that very well. So as a final year students, so you know that, so solving any engineering problem, it's having a two different way. One is using a conventional method. So suppose if I'm able to do uh, mathematical modeling, okay, especially as a engineers, we are very much know or we are having all the methods and etc. to solve linear problems. Okay, we all studied the linear problem. Say for example, in a circuit, if I am having this much number of resistance, and these are all connected in a fashion like that, series and parallel, this many are in parallel, this many are in series, as a overall effective resistance I will calculate. So that is a linear calculation. But in actual practice, it is a very, very complex one. It is a very, very complex one. Okay, so even as I already told, due to the aging of component, okay, due to their particular, because all the components are made up of from the material that is available in this earth only. So it is also showing its characteristics. Okay, so even though our objective is to study or know the electrical parameters, electrical point of view only, but that material is made up of from this earth only. So it shows its own characteristics, and it shows its own behavior of due to the aging and etc. So that cannot be predicted very much. So that is the reason why we are going for soft computing techniques. The very important advantage of soft computing techniques or some smart technique is there is no need of any mathematical modeling. Okay, so we are measuring certain parameters we are interested. Based on the parameters, based on the input, we have to do. Okay, so we have to do some optimization. That is, we have to do maximize the efficiency. So I am not here. I will not going to deal with any sort of equations. That is a very big advantages. So what the latest car or what is, especially these type of fields are very much suitable for the electrical vehicle field, because in a electrical vehicle, in day-to-day activities, the performance and behavior, how the driving pattern and all the terrains and etc, that cannot be keep on giving us a input, and we cannot develop the mathematical modeling. And once you start solving it, it will take very, very complex. So instead of that, the parameters interested, I'm keep on measuring, and that parameter interested, I'm giving as an input. Okay, I'm taking as a reference, I am giving certain input, comparing the particular two things, and the result of that, I will take some certain decisions. That decisions will be making the entire system as a maximum efficiency. So for that, a lot of things we can able to know: genetic algorithm, fuzzy logics, okay, and neural networks. So these are all the some soft computing techniques. Okay, so that is, of course, these are all implemented in the modern electrical vehicles. Modern electrical vehicles, all these having. So some vehicle may having a neurophysiologic controller. Very often they'll go for either genetic algorithm and very particularly fuzzy logic system. So because fuzzy logic system, it is very much suitable for give a instantaneous solution. So based on the present parameter, whereas neural network, we can have the integration like that. So the vehicle performance, and it will keep on collecting the integrated information of the performance of the vehicle. Based on that, it can give a decision. Suppose a bearing. Okay, so if you keep on using bearing, it may worn out, or if you keep on using any cable. Okay, so because obviously the electrical vehicle means from a power converter to motor, we used some power cables and all. So automatically it is having insulation. When the insulation failures, so that has to be keep on monitored. Even though that particular instantaneous of puncture or the failure of insulation is going to happen at one point of time, so we cannot always monitor. We instead we can use a neural network that can able to predict. They can able to predict the performance and when it is going to be really a problem. So at that time it will give warning. So likewise, so many smart computing, okay, soft computing techniques are available. So these soft computing techniques is very much used. So they are only dealing with the parameters or which are all the known things. With that we can able to make some decision, because obviously, so the decision making is a very, very important, especially in case of management. So it is similar to that of MBA and management only. So mainly the management people will be trained to make decision making, so they will be trained for decision making. Likewise here also, the soft computing technique that were identified is going to be only used for decision making based on this parameter. So how I'm having expertise on this type of design and this type of strategy, how this power can be controlled. So that there we have to develop our expertise. So because as I already told, the tools knowledge alone is not important. Our tools knowledge alone cannot make you survive in this field. Because I am very good in genetic algorithm, I am very good in fuzzy logic, I am very good in neural network, or I am very good in the uh, what I can say that composite, hybrid, okay, hybrid technology like neurophysiology controller. That alone will not make, if you are not having a domain knowledge. So tools knowledge alone is not enough. If you are not having a domain knowledge, especially how the really how much the power required, how much is the contribution required, when it is required, how much it is required. So the entire performance of the electrical vehicle or hybrid electrical vehicle you should know. Then only that is called a domain knowledge. Based on the domain knowledge only you can apply the tools knowledge. That is nothing but this type of technique. Then only we can give a very effective solution. Okay, so that is why the knowing the beforehand what kind of power management strategy and algorithm will be used can help one make better choice of devices in terms of size of engine, battery, and so on. So during the design phase, so that the same performance can be achieved by using a smaller equipment and making a best or optimum use of it. Okay, so once the system has been designed, okay, little further changes only can be done on this is same. So only we cannot dismantle and we cannot do that will be lead to a lot of uh, influence in the cost. So though it is still possible to improve power management algorithm from time to time in adaptive manner. Okay, so definitely this is required because various parameters within the system might change. Okay, so that's what we are going to see in this unit. This is the benefit of energy management. This is the benefit of management because not only design and fabricated or developed according to the design alone will not make you a record performance. Obviously, we have to incorporate some energy management, power management strategies. Then only we can able to get a full uh, performance or full benefit of the particular design. Okay, so based on that, here we have yes. If you see any vehicle, suppose if for in our case, I can take it as a hybrid electrical vehicle or any electrical vehicle. So these are all the inputs I'm going to give. So what is the auxiliary load demand, accelerator pedal input, brake pedal input, road and outside environment input. So measured through various sensors. So like vehicle speed, torque at the wheel. So these are all can be measured. So these are all the maximum possible inputs I can able to generate. Okay, for any vehicle performance or any vehicle power and management. So automatically that has to be processed vehicle system. That will be given to a vehicle system that includes the engine characteristics, gears, batteries, generator, propulsion motor, and other auxiliary loads, AC, air conditioner, and other electronic entertainment electronics that is available, all the accessories and etc. It also included the controllers like engine controller, fuel system controller, especially microprocessor based fuel injection system, transmission controller, body control. So this input is applied to any one or combination of two or more systems. So say for example, if I'm giving accelerator pedal input, that is not only going to given to the engine. Okay, so automatically that will the influence of the particular one will be given to the batteries. So batteries has to pump more electricity. So then it is given to a propulsion motor. So then it will be so that will be controlled by the controller. Okay, so then as a combination of power generator, so I have a combined power both from internal combustion engine as well as from motor that has to be properly transmitted to the powertrain using a transmission control. So this is not going to be the whatever maybe the input or parameters are identified. it is having influence on single system or single component. So sometimes it may be on single component, sometimes it may be a combination of components. So I have taken its entire system. So for this entire system, I have given, so as outcome from the vehicle system controller, so as outcome of that, the engine torque and speed, okay, and various power required demand, and how much is the voltage and current, and what is the battery SOC. So these are all the additional data, sensor data and information that I need. Okay, so based on that input on the system, I have to generate these things. So automatically that will be given to a power management algorithm. Then in turn, it will be effectively control the particular all the components or combination of the component. As a result of that, whole system will be working. That is what optimum decision result. Optimum decision result from power management to control gear ratio, throttle valve. Okay, how much the fuel air mixture has to be go, how much the battery current should be. Everything is decided by the battery management algorithm. For the battery management algorithm, input is not directly given. So influence of the particular input on the system. As a result of that, I can able to calculate how much power requirement, how much voltage, how much current, what is the present state of SOG, that is state of charge, and etc. is generated. That data and information is generated. That only has to be given to the power management algorithm. So these algorithm may be of anything. Power management. I may use fuzzy logic. I may use genetic algorithm. I may use ant calling algorithm. Likewise, so many soft computing technology is there. Mainly, we are not using mathematical model because once the here very clearly this input is given. So instead of I'm just making a mathematical modeling of the problem. Okay, so I can able to use that the information and data, and I can able to finalize what sort of a decision, optimum decision I can take. So how much should be the fuel air mixture? How much should be the fuel from throttle valve? How much should be the battery current? And what is the firing angle of any power electronic circuits or any duty ratio in case of any DC converters used. So if I am deciding that, I can able to operate the system by which the required input. Okay, so based on the accelerator, based on required input can be converted to a required output. Okay, so by that I can able to mainly manage the power and energy. If in the absence of power management algorithm, what will happen? There is a lot of confusion, lot of wear and tear will happen. So I may drain my battery. So maybe that initially or during the normal running period of any mild hybrid electrical vehicle. So here I want to say one example, mild hybrid electrical vehicle. So in case of mild hybrid electrical vehicle, the majority of the propulsion, majority of the period, power propulsion will be created by my internal combustion engine only. So my motor or my electrical concept will be coming to the picture only at the time of starting and as well as time of ideal stoppages and as well as during the regenerative braking. So instead of that, if a motor is keep on engaged during the normal running also, what will happen? So my state of charge of the batteries will be depleting, decreasing very drastically. So automatically when the vehicle is at the time of stop, okay, so automatically my IC engine will be stopped. When I'm going to start, I have to depend on the motor, but at the time I couldn't start. So a proper power management and energy management strategy or algorithm is not there in case of a hybrid electrical vehicle as well as an electrical vehicle. There will be a very fatal, okay, fatal here. It will be, so I cannot get a assured or desired performance of a vehicle. So it is like a very soul. It is like a soul of any vehicle. Soul. So all the hardwares, all the components are assembled or having it as in a sequenced way. It is connected as a system and all. But they are all hardware. This is only a soul. If a proper soul is not there, there is no use of. So vehicle will run, vehicle will manage, but obviously operating the vehicle, okay, will not be giving a economic. So I cannot give a maximized efficiency, maximum fuel economy. I cannot have a maximized performance and etc. This is the reason why so students should know, uh, especially the power and energy management. So as I already told, so expertise in the particular is okay. So if I want to implement this algorithm, I have to go for a rule based system. So that is what in management. So that is why usually we very often we heard that management school only is a business school, management school. Okay, we are not calling them as a management college, management university, like the management school, management business school. Why they are? So mainly schools and all. Okay, people learning with a lot of rules. Okay, a lot of rules will be there. So if you have properly followed the rules only, you can able to really acquire or gain some knowledge. If you are not knowing the rules, or if you are not able to follow the rules, certain rules, so you cannot able to learn. That is what in schools and all we can able to see a lot of rules. That is the reason why schools. In colleges, mainly what will happen? They'll teach and go. Okay, so because you are all already matured enough and able to adapt yourself to the particular system, and you know how to control yourself and etc. That's the reason why we are calling. So, but whenever talking about management thing, they have to follow certain rules. Okay, so they have to study some concept as a rules only. If it is so, you have to do like this only. A fixed certain. So the same thing. Okay, if I want to manage the power and energy also, definitely it is a rule based one. Okay, so very important. It's a rule based system. Okay, so that is what here very clearly is explained. Okay, so these are all the strategies. First, we see the strategies. There are many strategies are available. So mainly to optimize the engine operation and point and region. So for the given torque speed plane, or for a given fuel economy and emission to be achieved, I have to maintain the engine operation in certain point. So this optimum engine operation point may vary or may be increasing or decreasing based on the constraints. That is how much the torque speeds plane and how much should be the fuel economy, how much is the emission allowed. If it is changes, automatically this optimum point also will be changing. So for a given constraint, I have to give the optimize the engine operation, and very importantly, minimize the engine dynamics. So especially in a hybrid electrical vehicle, the operating speed of engine is regulated in such a way that fast fluctuation. Okay, so automatically that has to be minimized. Engine dynamics should be minimized, and minimize the engine ideal time. So as I already told, during the ideal stoppage signals and all, what will happen? So the engine is keep on running, but there is no need of any output. Vehicle need not to move. Vehicle need not to run. Okay, at that time also the same amount of fuel only is consumed because of the vehicle is stopped. So the fuel consumption will not be going to be nil or very negligible. The same amount of fuel only is going to be taken by internal combustion engine. So automatically, so this is called ideal time. So that ideal time should be stopped. So if certain ideal times more than that, my engine should be stopped, or it should be put it in off condition. So likewise, optimize engine on off time. Okay, so engine on off time also should be optimized. So based on the driver's habit, road condition, traffic situation. So that is the one strategy, and maximally capture the regenerative energy. So as we are now know that hybrid electrical vehicle configuration, especially the mild hybrid electrical vehicle configuration, it is exclusively incorporated. Okay, for the fuel economy because of the regenerative energy capturing. Okay, so maximum regenerative energy capturing should be there. So as I already told, if a 100 kilometer vehicle, 100 kg vehicle running at 100 kilometer per hour, if it is ideally stopped, then it is coming to a rest position, means around 0.16 kilowatt hour of energy can be saved. So that complete energy should be captured. So this much energy is available, or this much energy can be captured, but out of the 0.16 kilowatt hour, I can only capture 0.1 or 0.9 kilowatt hour remaining rest of thing I cannot capture means that is not a good strategy. Okay, so I have to do a maximally capture a regenerative energy, and another one is optimize the state of charging operating window of battery system, because state of charge of the battery is very important. So from a fully charged condition to a completely discharged condition, there only a fractional voltage difference only will be there. So I have to keep always at a particular percentage. Okay, so particular voltage that has to be maintained state of charge. So by means without compromising on the battery life and fuel economy. Okay, so I should not operate only the internal combustion engine to charge the battery. Okay. At the same time, when the internal combustion engine is producing a propulsion power, so all the power cannot be completely going to be used for the traction, or it will not be transferred to the tractive purpose or to the wheels. So portion of power will be always available. That has to be diverted to the generator, which is coupled to the shaft of the internal combustion engine. So a small generator there. So only when the vehicle running, okay, or when the normal running, it has to be provide the charging, okay, of the battery by which I can able to maintain. Likewise, optimize the operating point of electrical motor. So the electrical motor also should be with a specified torque speed plane, it should be operated. Okay. So usually at the initial condition, in order to overcome the moment of inertia of the vehicle, and also at standstill, the motor can able to generate very high amount of torque. We used to prefer a motor operation at this time of starting instead of using an internal combustion engine. So after coming to the vehicle start moved only, we are going to engage the internal combustion engine. After that, we are going to switch off the motor. We are only going to charge the battery, and simultaneously, the internal combustion engine will provide the traction power, so or the propulsion power. So this is I'm telling about in case of a mild hybrid electrical vehicle configuration. So this may be sequence may be varying. You know, you already studied power flow analysis. So different modes of operation for series parallel and complex configurations also. Complex configurations mean front and rear wheel is controlled by a different configuration. Front is having a series parallel where it is dominant by the internal combustion engine. So back wheel, rear wheel control may be having a series parallel, which is dominant by another one. Suppose in the front, it is electrical motor is dominating. Suppose a rear wheel is dominated by the internal combustion. That is called complex configuration. So we know very clearly all the power flow analysis for all the configurations. So that we have to incorporate. So as I already told, these all strategies can be implemented or properly managed only if it is follows certain rules. Certain rules. That is the reason why this is a very important one. So this is the reason why majority of the electrical vehicle, the power and energy management system, okay, is by rule-based energy management system. Rule-based energy management system. So I have here taken so one mild. It is maybe a mild electrical vehicle configuration. If you see that, if you see, I'll show it. If you see that, so from the zero, okay, so from the zero to 8 kilowatt. Okay, so usually it is required at the time of positive propulsion power required. So at initially we are only using up to this power requirement. We are only using electrical motor. So this is a case of you can take it as up to some 30-40 percentage of the hybridization. So up to 8 kilowatt to 40 kilowatt IC engine for propulsion and charging. Okay, so I have used from 88 kilowatt to 40 kilowatt. Internal combustion engine alone is using, but that internal combustion engine taking care about the propulsion and as well as charging of the battery. Okay, so here beyond 40 kilowatt, if I need a propulsion power, there I have to engage once again electrical motor, but the electrical motor is 0 to 30 kilowatt, whereas my internal combustion engine 40 kilowatt means this is going to vary. So I am going to fix a base as a internal combustion engine, okay, up to 40 kilowatt. Beyond that power, it is a varying from 0 to 30. I can able to engage from the electric motor, by which I can have maximum of 70. If full electrical motor power is utilized 70 kilowatt, so if fractional some 50 percentage only means 15, so 55 kilowatt, 55 kilowatt. So if this much power is required, I'm going to use them. Okay, so then I'm using 40 to 60. Okay, so I'm going to vary internal combustion engine. When it is beyond 40, I'm going to vary only internal combustion engine, but I'm making electrical motor as a fixed one, base one, 30 kilowatt. Because we know that, so whenever a power required from the internal combustion engine is more, the efficiency is decreasing. Efficiency is decreasing. So whereas up to this 40 kilowatt, it may have some 50, 55 percentage of efficiency. If beyond that also I can able to get, but whenever I'm deciding that, it may be efficiency may be coming 40 percentage. So during that time, I'm making electrical motor power 30 kilowatt will be there. Beyond that, up to 60 kilowatt, 40 to 60, I'm only engaging internal combustion engine, which is varying, sliding one. Okay, so automatically here the efficiency problem will be addressed. So this is what power. So likewise, usually whenever any decreasing or braking occur, so regenerative braking will be there. So my motor will be acting as a generator. So automatically up to maximum 30 kilowatt. Okay, this is instantaneous power. Instantaneous power, and I can able to capture. I can able to capture through a proper converter. I can able to store them in a energy storage system, especially mainly in a batteries. Okay, that is what described here. That is what described. So it is rule based one. So up to this means I have to engage this one only. From 8 kilowatt to 40 kilowatt, I have to engage this one only. Internal combustion engine only, but the internal combustion engine additionally has to be taken care about the, because fuel consumption will be the same. So automatically I can able to engage some portion of power for which is coupled to a generator. So this internal combustion engine also running a small generator which is used for charging purpose. So after 40 kilowatt, what will happen? So I have to engage my motor also. Okay. So up to 30. So whenever it is going beyond 70 means automatically what will happen? So plus 30 plus 40. Okay. So I am going to engage the my internal combustion engine. So I am not going to increase the further motor rating. Okay. So because only I preferred 40 to 60 kilowatt operation of internal combustion engine beyond 70 kilowatt, not between 40 to 70 kilowatt. Why? Whenever you are increasing the power, propulsion power, or traction power, it can be generated, but the efficiency of the internal combustion engine will be decreasing. Okay, it will be decreasing. It will be like this. Okay, it will keep on going. After sometimes it will be decreasing. Okay, this is what I identify. So that decrease in efficiency is only allowed beyond the requirement of electrical power motor is 30 kilowatt and beyond the requirement of 40. So more than 70 kilowatts only, I am just allowing my internal combustion engine to increase further up to 60 kilowatt. So because this is a region where the efficiency is decreasing. Okay. So this is what I explained here. And as I already told rule. So for this, for what I told now, no, they are all converted as a rules. That rules will be incorporated in the my soft computing techniques. That rule will be taken care by the soft computing techniques. Automatically, in any situation, that rule will be followed. So automatically, we can get a maximized efficiency. So rule one: at low power demand and low vehicle speed, use electric motor only. So from this, I can able to add 0 to 8 kilowatt means at low power demand and low vehicle speed, use only electrical motor. Rule 2, use both electrical motor and IC engine at high power. So where from 40 kilowatt to 90 kilowatt, it is called high power demand. So it is slightly brown, dark, and black. Okay, it's very high. So you have to use an electrical motor and IC engine at high power demand state. Rule 3. At highway or stable driving condition, use internal combustion engine. This is called stable driving condition. Only use internal combustion engine. Okay. So rule 4. Use the internal combustion engine to drive the vehicle and power the electrical motor to charge the battery depending on the SOC level of the battery. That is what happening between 8 kilowatt to 40 kilowatt. If the SOC is too high, do not charge the battery. If the SOC is too low, charge it as much as possible. Okay, so this will be encounter two situation. So my battery may be reached charging, full charging. Okay, too high means above 90 percentage. So automatically no need to charge the battery. Only a floating charging is enough. Okay, so floating charging, which will only compensate, which will only require very less charging current beyond 90 percentage. If it is too low, okay, flood charging, flood. Okay, so more amount of current is required to charge from the generator which is coupled to the internal combustion engine. And rule 5, maximally using the regenerative braking. So here, whenever we are decelerating, we are totally cut down power, okay, and we are that means we are decreasing the speed or we are applying a braking means I have to use regenerative brake. Maximum power we have to get it. Maximum power means available power. We know some idea how much will be there. From that we have to get it maximum. That has to be stored in the battery or any other energy storage system. We know that ultra capacitors and etc. So in that way I have to store the energy. So whenever in further running, okay. So because they are all capable of providing uh, energy for about few minutes only. Okay, ultra capacitor, but capacitors fraction of second only, milliseconds only. So we used ultra capacitor, which is having a very high capacitance, capable of storing the energy for certain minutes, and likewise discharging also certain minutes is possible. And rule 6, optimize the overall efficiency of the vehicle system by adjusting the output power. Use electrical motor if this action will be shift operating. So that's what here. So very in understandable form. This cannot be mathematically modeled very easily. Okay, it will be very complex. It will be very complex. Likewise, above 70 kilowatts. So I'm encasing full motor power. So instead of that, I'm just using rules. I'm just using rules. These rules, in turns, that has to be placed in the specifications. So here, that is what I depicted in a drawing. So here I am going to give you a vehicle speed, battery, vehicle speed in kilometer per hour, vehicle power in kilowatt. What's the state of charge of battery? I am doing. Okay. So here I am already all these rules are okay. So fuzzy rule that will be converted as a fuzzy rule base I am created. Based on that I am created a specification. So I am creating a fuzzy reasoning deep-specification. When the input of the three is given, for that particular rule is fired here. So, if, for example, in previous case, so now I'm giving vehicle speed is certain kilometer battery charge, but vehicle power is zero means it will be understand that so no power, but vehicle speed is going, so it has to decelerate. So whenever I'm withdrawing the vehicle power in terms of kilowatt, it becomes zero. It will be understanding that that has to be go for a regenerative braking mode. So automatically that okay, what is the rule 5? Rule 5 will be fired. Rule 5 will be identified. For that, what is the specification? That will be done, specification and decision will be taken. So fuzzy logic output motor, so automatically that will be acting as a generator. Then my power modulator will be in the inversion mode. So automatically what will happen? So what's the power that is generated? Using in inversion mode, it will be converted from AC to DC. Then that particular DC power will be stored in a battery. Okay, that is what final decision. Engine power, motor power, how much should be there, etc. Okay, so in addition to that, for final decision, what is the present engine speed? What is the optimal operating power? That also should be given for final decision. So this will be only taking a decision, defacilification or output, physiologic output, it is based on the three parameters only. Okay, so these three parameters only. Based on that, in addition to that, for final decision, I may need engine speed, which in turn will decide optimal operating power. Okay, so that will be taken for final decision after the output fuzzy logic control. Okay, so this is a symmetric diagram or any black diagram of any implementation of power or energy management in any electrical vehicle or hybrid electrical vehicle conversion. So the first method is rule-based energy management system. So of course, any management system means that has to be follow certain rules. So if there is no any rules followed, you cannot able to manage any system. Okay, so rule-based management system. So in our case, in case of, for example, I have taken a mild hybrid electrical vehicle configuration. So it is having so out of maximum 60 kilowatt. So if you see the motor is 30 kilowatt, total is 90. So out of the 90, only 30 kilowatt is motor. So 30 divided by 90, one third, one third. Okay, one third. So one third is a hybridization. One third is the hybridization. That 33.33 percentage. 33.33 percentage is hybridization. So this is nothing but it is. I can take it. I can tell it as a mild hybrid electrical vehicle configuration. Mild hybrid electrical vehicle. Sorry, time I will. Yeah. Okay. Up to this, I'm stopping. Okay.
Sir, time 10:05, sir. Attendance.
Yeah. Yeah. I forgot. Okay. With this, I'm stopping. Okay. We'll take attendance.